So guys, going forward, now let us first understand that what are byte addressable memory. A byte addressable memory is a memory in which every byte has an address, right? Such a memory is called byte addressable memory. So let us take an example. Suppose this diagram represents your physical memory, right? So you can see that each row of this physical memory comprises of 4 bytes, that is byte 0, byte 1, byte 2 and byte 3, right? Now your physical memory is a byte addressable memory, that is every byte has an address. So if the starting address of the byte 0 of the physical memory is say 0, then the address of the next byte will be 1. Address of the next byte will be 2 and so on, right? So every byte of the physical memory has an address, and therefore physical memory is called byte addressable memory. In fact, your virtual memory is also byte addressable memory. So every byte has an address. And you can see that the addresses are actually in continuous order. Right? That is, every consecutive bytes will have consecutive addresses and so on. So suppose if you have a pointer which points to some memory location, let's say that PTR is a pointer and this pointer points to this address, right? Let us say that this address represents 65. Now if you increment this pointer value, it means that this pointer will now start pointing to the next byte in the physical memory. So this pointer will start point to the byte number 66 in the physical memory. So byte is the lowest unit of memory that can be accessed, right? So that is why we need to perform Boolean operations in order to manipulate memory at a bit level. So note that in your C program or in any programming language, you do not have a data type which represents bit, right? There is no data type called bit in any programming language. So the shortest data type that is available is byte in C or any other programming language, right? In fact, in C we have a shortest data type called char. So it means that using primitive data types of a programming language, the smallest unit of memory that you can access is a byte. And whenever there is a scenario that you need to access or manipulate a particular bit present somewhere in your physical or virtual memory, then you need to apply Boolean operations such as AND, or not, right? So it is for this reason, because your memory is byte addressable memory, there are no data types called bits in the programming language, and hence you cannot access memory at bit level. So the conclusion is that our physical and virtual memory are byte addressable memory, and every byte has an address. So when we say that suppose this physical memory is 4 GB in size, let's say your computer has a physical memory or RAM which has a size of 4 GB. Now convert this 4 GB into bytes, you will get 2 raised to the power 32 bytes. Now every byte has an address. It means that your RAM chip has 2 raised to the power 32 memory locations or memory addresses. Now the question is that what will be the address of the last byte of your physical memory? The address of the last byte of the physical memory will be 2 raised to the power 32 minus 1, right? So if you have a 4 GB RAM, then the address of the last byte of this 4 GB RAM will be 2 raised to the power 32 minus 1. And remember, addresses are nothing but these are just numerical indexes which represents a particular location of a byte in a memory.